All right, I have returned. And we're going to figure out why the turret is spinning like this. Okay, so let us add some more debugging to the script to figure out what's going on here. I think I'm just going to get rid of the debug draw stuff. I don't know. Here's a question. If we go to the asset lib and I look at, okay, no, okay. It's like, is there a convenient way to just like remove add-ons? I'm just gonna delete, yep, that folder. And then, is it plug? Okay, good. That's all sorted. All right. So why are we rotating so much? Well, it's because of whatever rotation amount is, right? So let's add some logging. Rotating turret current is current rotation. Target is target yaw. Rotation amount is the calculated rotation amount. So if we save that, okay, and we can see some stats here, right? So current rotation point. Look, it goes from 0.15 to 0.31. Target. So the target stays the same, roughly. The zombie's moving, slightly because it's trying to get to where it's going, right? And then we have a rotation amount. So something's not right here. So what does rotated do? Okay, this returns a copy of this transform rotated around the given axis by the given angle in radians. Axis must be a normalized vector, which it is. If the angle is positive, the basis is rotated counterclockwise around the axis. This method is an optimized version of multiplying the given X transform, yada yada yada. Okay. So here we're changing turret top mesh dot transform. Here we're using global rotation. Should we just use rotation here? Does that matter? Apparently not. Oh yeah, the zombie's getting hit, but the turret does 0 damage. That's what's going on here with the zombie shaking. If I can catch it with the... Okay, so like the turret right now, negative 1.54. That's interesting. What's going on here with the rotation? Why is current negative 1.55? Right, so if we're in radians, then the rotation would be... it should be either negative or positive. If it's like normally when you place the turret, right, it's facing that way. Oops, there we go. Can we catch it? What? Okay, so pretty close. Right, so facing upwards should be either 0 or 2 pi or negative 2 pi. What's going on with that? So if we disable the part where we actually change the transform and we're just logging, what does that look like? Okay, the values don't really change, which is good. That's a good sign. Let's take a look at the turret. top. Its rotation is 22.7 degrees. If we change it to 0, run the game, what does that look like? Okay, so current is 0. Target is negative 0.79, which is interesting, right? So this should be the target, is this guy right here. So why is the target negative 0.79? Right? If the target was like just to the right, then you would think it would be half of pi, right? Half of 3.14. If it was right behind, then it would be 1 pi. Or it could, you know, rotate around the other way, right? And so it would be negative. That's so weird, right? So something about the target angle is wrong. Target yaw, right? And that makes sense because I just accepted Copilot calculating this thing. Which, to be fair, if you want to find the angle around, right, so what am I trying to say? So you have, I think we established X is going this way and Z is going this way. And what you want to do is you want to find the number of radians trying to recall trigonometry. Hold on, let's just Google. Yeah, the angle theta between the positive x-axis and the ray from the origin to the point xy confined to negative pi to positive pi, right? That makes sense, right? Except here x is y. Should this be the other way around? Should this be like, hold on, should this be z and x? Right, the positive x-axis, right, which is the x's in, okay, between the positive x-axis and the ray from the origin to the point. I don't know. Let's just try that. Okay, target is 2.36. That is more believable, right? That is a more reasonable looking number. So let's turn on the rotation part again. Okay. Oh right. I wanted to test something else here. So let's turn that back off so we're not doing silly things. So if I set this to 0 and we see the log, we can see that's 0. If I set this to 180, so it's facing that way, 3.14. That makes sense. What's interesting here, rotation amount, 3.14. That's wrong. Right, so rotation amount is supposed to be like confining. Oh, right. So this is definitely not right. Lerp angle linearly interpolates between two angles by param weight. Okay, look at their example. So they have a min angle and a max angle. Let's function lerps through the shortest path between from and to. Okay, and then elapsed. I don't know that that's what we want to do. I don't know that that's what we want to do. So essentially what we're doing here is we're saying max rotation is some value that is a fairly small value, and we're dividing it by how much we need to rotate. Is this reasonable at all? I feel like it's probably not. Okay, so that gives us rotation to target, max rotation, and then I also want to know what the clamp is, or the yeah, basically what that whole calculation is, where we're doing this division and we're clamping it. What does that look like? Okay, so rotation to target negative 0.77. That makes sense because we want to turn left. Max rotation is that amount. Clamp is a fairly small value. But that doesn't do... Yeah, none of this is going to work that way. Right? Because... Oh, right, because this is not... This is not the rotation amount. This is the lerped angle is not even sufficient. Target angle, right? And the rotation amount is the lerped target angle minus the current rotation. Like, it's what we're trying to get to minus where we're at. Right? So now, the rotation amount is a tiny amount in the direction. And the other things look right. So if we turn this back on, that's the wrong way. It is at least not... It's interesting. That is interesting. 5149. Like, I see... It says it's rotating, but I don't see it rotating. It's kind of weird. Oh, it's kind of... It's... Okay, it thinks it's where it needs to be, but it's wrong. It's, why? Okay, current and target. Rotation amount. So all those things look great, except for the part where it's facing the wrong way, right? So it thinks the target is this value. What is this in degrees? No, don't. In degrees. Great. Ooh, 135 degrees. That is almost believable. No, I don't want to do that. I wanted to go to remote. Make sure we're looking at the right node. 135 degrees. So that checks out. But that's wrong. What we want is something like this, 217 degrees. So why... What are we doing wrong here? No, I don't want to pause. Okay, let's just restart. Oh, it's turning. Very slowly. Okay, so things I observe. Rotation speed needs to be bigger. Bigger. Is this actually having any effect? No. All right, let's restart and start game. And okay, interesting. It's wrong. It's off by 90 degrees. And, you know, in principle, it's right. It's just off by 90 degrees. I don't suppose, what kind of methods do we have on the vector? It'd be fun if there was a method to do exactly what I'm trying to do. Rotated sine, signed angle 2. So that's not quite what I have in mind. 2. And it returns a float. I wonder. Let's just try things. Interesting. What is forward? Model front. Ooh, that's not quite right. Wait, hold on. Is this just a this is a I need to take the current. Wait, no. If I'm turret top mesh global position, I can get the signed angle to current target global position. And then this just goes away. I might have to restart to see that happen. Not quite, huh? Oh, apparently I can place turrets in the water. Also, that didn't work. There you go. I mean, they rotate. I'm not sure exactly what they're rotating towards. Yeah, that's not quite right, is it? Okay. Return the signed angle to the given vector in radian. The sign of the angle is positive in a counterclockwise direction and negative in a clockwise direction when viewed from the side specified by param axis. What if I did just angle 2? Returns the unsigned minimum angle to the given vector in radians. What's that mean? Unsigned minimum angle on one axis. That's interesting. How would that work? No. Okay, I think we can get rid of all the extra logging here. Okay, stop it. I don't think this is gonna work, but we're gonna try and see what it does. Yeah, no. Okay. Rotate object local, precision errors, obtaining information. How do I get angles from a transform? You don't. You must have stopped thinking in angles. You do want the transform. Yeah, I only want the transform to happen in one axis. Rotate object local is interesting. Maybe I should just be using this. Rotates the local trend. Well, I mean, we're not trying to rotate ourselves. We're trying to rotate the turret top mesh. I guess there is a rotate Y, so we could do that. Rotates the local transformation around the Y-axis by angle and radians. Okay, I think let's take this, and then we're gonna undo a couple things because we were at least getting a little bit more motion with this. And then I'll put this back, and we can. So stuff is happening. That's good. We want stuff to happen. And we're just offset 90 degrees for reasons. Let's keep reading. Yeah. Okay. So. Hey, look. Yeah, this is probably a thing where I just need one of these to be negative, huh? Ooh. Z and X. Solid, that doesn't seem right. Like, I feel there should be a better way. Like, instead of doing this, I really like the other thing. So this is interesting. Angle 2 forward. Still is not right. What's interesting, though... Yeah. Don't have enough scrap to keep on building those turrets. There we go. Doesn't work. The target yaw is wrong. I mean, maybe it should just be this. Maybe I could... Let's just go backwards a couple steps. Yeah, that. And restart. You know what they say: if you don't first, if you at first you don't succeed, try again. We're doing a lot of trying. I mean, they're definitely moving and responding to the zombie. It's just off. I mean, if you're gonna do that, why don't you just say negative pi? Negative pi over 2. Negative pi over 4. I don't know. What is the why is this off? Ooh, that looks really good. It's like it's facing away from. Wait. If that is making it. Yay, it faces the zombie. There we go. Alright, cool. That's a lot of work for such a simple thing. Okay. We'll make the turrets actually do damage again. I'm gonna need to do all sorts of like balancing with this. All right, here come the zombies. Now, a thing I notice. Okay. Yeah. So this is where the turrets are able to fire before they are aiming at the zombie, right? I think a couple of things need to happen. One is that the turret as a we're gonna double its rotation speed. Excuse me. I also, bigger picture, I need to think about how this works, right? Where the if you fail the scenario, it doesn't save, right? So you get whatever scrap you had earned prior to starting the scenario. When you complete the scenario, if you don't you should actually, yeah, here, hold on. Let me capture this as a thing to do. Think about what I want to say here. Can you create a GitHub issue for me that will, for the purpose of reclaiming all placed obstacles at the end of the scenario to refund scrap automatically? Oh, it will auto send it when it thinks I'm done. Usually I just hit enter. All right. Anyway, back to the topic at hand though. So yeah, it does turn pretty quickly, but it really should. The other thing that we need to do is to have some kind of graphical indication that the turret is firing. Also, the range of detecting enemies for the purposes of turning the turret needs to be different than the attack range, I think. Okay, let's see what this is. Automatically reclaim refund scrap for all placed obstacles at end of scenario. Okay. Allow. Okay, so in shooting obstacle, we have this attack range. We want an attack range, but we also want a export var detection range, which should be bigger. Can you put... Oh, you know what I should do? Can you put that issue in the phase 3 milestone? Great, and so this will update the milestone for the issue that was created. Great. Okay, find nearest enemy in range. So nearest distance should be probably not attack range +1. So how does this work? We find all the enemies that are in the enemy group in the scene tree. We iterate over the enemies. If they are enemies, we get the distance to them. We say that if the distance is less than the attack range, distance is smaller than the, so we're trying to find the nearest enemy, right? But there's a rule, and that rule is the... Oh, I see. Wait, is this redundant? Like if both of these have to be true but nearest distance starts at attack range, then really what we want to do is we want to just do this, and we want to change this to be based on detection range. Right? Oh, right. So that breaks something that we're assuming that should happen here, which is that when we return nearest enemy, it is an enemy that we can attack, right? So if we have the concept of I've detected the enemy to attack, but I can't attack it yet. Another aspect of this is that once we pick an enemy to attack, we don't give up. Think about how this works. Right, so we have this detect and attack enemies, and it sets the current target, right? And it says if there is a current target, then we perform an attack. Do we want to have... If we want to have it so the turret will start locking onto things at a further distance, but... Thinking about this. How's this going to work? Do we want... Do we want to reevaluate? Well, we already have a timer, right? The timer is dictating when we are looking for enemies on a detection interval. We run this. Oh, right. So every detection interval, we are rescanning, and we pick whatever the closest is. So the turret will shift targets based on whatever the nearest enemy is right now. I think what we would then need to do is have a var can attack current target. It's either this, or we could have like separate variables to hold the node 3D or something like that. I think a Boolean is fine. If we do this, then var can attack false. Okay. When we look at the distance, if the distance is less than the nearest distance, we can set the nearest enemy. If the distance is less than or equal to attack range, we can say can attack is true. Then we're going to change this function. Can we return something like this? Yeah, an array. And then okay, can't do that. Can we do that? No. That's too bad. Okay, and then we do that. That keeps our logic all contained into this one function. So what does that look like? Right, so now when enemies come in, okay, why aren't these aiming? Why is nothing happening? Hold on, let's reload. That's weird. Attack range, detection interval. Export detection range. But it's not there. Okay. Project. When in doubt, reload the project. Ignore all the warnings from those things. That's weird. Extra things that we got when we added that add-on that we don't need. Okay, so there we go. We have detection range, we have attack range. Great. So when we start the game, let's go back here. Let's start with Campfire Survivors. So I'm tired of looking at that first level. Brainless says, all right, annoying thing done. Well, until the second round. Sure. Okay, this is better. The turrets might be a little overpowered now. We can't hit 4 to go speed 4. We can go faster though. Yeah, turrets might be a little overpowered. So I think I should definitely make it so the turret cannot start attacking until it finishes facing. So can we just win the scenario by putting 3 turrets down? Yeah. All right. It's a little overpowered then. That'll be something that I had to start thinking about in terms of like balancing between the different defenses. Like, you should have to make it through the scenarios, have like static like walls and stuff to hold back the zombies, and then turrets to attack the zombies, and eventually get to the point where you have to like route them and do like trap tunnel type stuff, right? That's kind of where I was imagining things would go. All right, let's see. Do we clean up things? Great. So with the basic turret, one thing we want to be able to control is, can we attack yet? So the way... excuse me. What we're doing now is we're calling attack, perform attack. So there's not really any way for basic turret to change that behavior of doing that. Think about this. I guess we can thinking bar ready to attack. This will default to true. And this is maybe not good object-oriented coding, but I'm going to do this. I'm going to say, oh, right. I didn't implement, oh yeah, that's the other thing. I didn't implement checking can attack current target. That's why things were a little overpowered there. Okay, so now we'll respect can attack current target, and we're going to add another ready to attack member. And then basic turret will be able to control ready to attack. So if there is some rotation to do, we do do it. Otherwise, we say ready to attack is true. We say ready to attack is false. Yes. And then, if there is no current target, we're not ready to attack. That's redundant, but it's fine. Then we also want to, let's see. Oops. On ready bar animation player. We have an animation player, right? Yep. So if we're coming back to the thing that I said I was going to come back to. If we don't have a current target, then we play the idle animation, which is fine. So ignore that. Cannot call method play on a null value. Oh no. We have animation player, but the animation is called idle turret. Okay. What's up with this? Line 34. Line 34. This is because, so I made the choice to make a lot of these nodes have the tool annotation because that would allow us to enforce certain requirements on you have to like provide a health node, attack node, those sorts of things. A consequence of that is it seems like I have to click reload current project a lot more to keep things up to date. On the other hand, now rotation happens in the editor, which is cool. All right, sure, start game. If we put down some turrets, where we're kind of idly scanning. I think I have a thing in the backlog to have some kind of indication of like turret ranges and stuff. Okay, zombie, you're not doing well here. Okay, you're supposed to be aiming at them, but you didn't. Oh yeah, we need to stop the animation is the thing, right? So if there's a current target, stop the animation player. I guess theoretically, I wonder. I don't know if you can really parameterize these things, right? So it's fine. Start, play. Oh, and just gave up, huh? That's so weird. What's going on there? Is there like a reset? No. Pause, stop. Let's see. Yeah. If animation player dot. Can we just hold on? What's that? What is this? It's a string. It's an empty string. Okay, stop it. And No, we don't want to do that. We want to reset. Is it dollar reset or is it... Hold on. How do things work? It's just reset. Okay. Okay, so it reset, but it's not... And now it's idling. Now it's not aiming the turret anymore. What's up with that? If the rotation amount is large, then we set ready to attack false, and we rotate the turret top mesh. Rotation amount. If the rotation amount is small, we say ready to attack is true. Okay, let's add some logging. Because I can't really tell what's going on here. Logger. Okay. Yeah, no target detected, it says. That's interesting. Oh. No target detected. If current target is not set. Why isn't current target set? We set it from result. We set nearest enemy. If distance is smaller than nearest distance, which is based on detection range. Which is 25. Doesn't make a lot of sense. No target detected. Rotating target. Rotating turret. Well, it's rotating the turret because it isn't able to rotate the turret. Okay, so let's one thing at a time. Let's pull out all of the stuff with the animation. I'm assuming there's some kind of conflict there. Let's restart. Okay, so if we put down a turret, yeah, it aims. Oh, time does fly. Something I'm thinking about here is that I feel like our lerp stuff is not great. Max rotation is this rotation speed. Should this be the other way around? Like, it feels like it's slower. Oh, now it's quite fast. Okay, great. A little bit more. I wasn't really... Okay, it's so close. It's so fast, rather. Yeah, it really snaps in there. I think that's a thing where the turret rotation speed could be slower. Game? Oh, right, I'm paused. I can't do anything while I'm paused. It just like snaps into place, and that's not quite right. What if this was like 10 again, or one? One is is definitely too little. No. Okay, so there's definitely something wrong with that change I just made. To do this shouldn't slow down as it gets closer. Fix this. Yep. And to do animation handling causes us not to rotate properly. Fix this. Okay, so I'm gonna pause here for now. We're going to kind of summarize. Yeah, that goes away. Don't need that. Yeah. So I'm gonna push this up to the. I'm gonna get a pull request going. But it's about lunchtime for me, so we're gonna wrap things up here and raid out. I want to say thanks so much for coming out to the stream today and hanging out and being here. It's nice to have some company as I,